In the previous lecture, we talked about something called promise composition. We saw that the then, catch, and finally methods actually create a new promise from an existing one, making it more sophisticated by adding more logic on top of the previous promise logic. This way, we can chain promises together and create a sequence of promises. On the other hand, the way we demonstrated this used callbacks and the catch, then, and finally methods. In the lecture before that, we saw the magic of async-await, the newer syntax that allows us to write promise-based code without using callbacks in a way that looks synchronous even though it's actually asynchronous under the hood. We know it's the recommended way to work with promises. So what we're going to do now is combine the idea of promise composition with the async-await syntax. We'll see how we can achieve the same thing without using callbacks. To do this, let's go back to the example from a couple of videos ago, the one with the start and go functions. Just to remind you, we had a go function, a simple function that logs a message and then calls start and then logs another message. It logs go1, and after start finishes, it logs go2. Inside start, we did something asynchronous, which meant we turned it into an async function. We logged start1, then created a promise but didn't wait for it, then logged start2, and then awaited the promise before finally logging start3. What we saw was that async functions actually return as soon as they hit the first await. The await signals the function to return, and all of this happens instantly. The second part of the function is basically compiled into a callback function and registered using the then method of the promise. So when we call start from go, we actually log go2, the second go message, before we even get to the third start message, because we're not waiting for the entire start function to finish, just the synchronous part. Now, if we look at the start function, and I'm using TypeScript here to get some type information from the editor, if we hover over it, we see something interesting. Even though it looks like the function is void because there's no return statement here, if we hover over it, we see it actually returns a promise of void. This is something important to know about all async functions. They always return a promise. The compiler takes care of that for us. But what is this promise? In other words, we know that a promise represents two things, a time of completion and a result. So what is the time of completion here, and what is the result of the promise that the compiler builds? As you can probably guess by now, the promise we receive here is the promise returned from the then method that the compiler builds under the hood. The completion time is when the second part of the function, the code that comes after the await, finishes running. And the result? Well, if we return something from the function, that becomes the resolved value of the promise. If we don't return anything, the promise resolves with void. So it's a promise of void. What if there's more than a single await? Well, in this case, this is compiled into a chain of then calls, just like we saw in the previous video. And if you wrap the await in try, catch, finally blocks, it also chains catch and finally operators. What we get is the promise returned by the last operator in the chain, representing the final result of the function. Now that we understand that the start function returns a promise, it becomes very easy to make the go function synchronize with it, or in other words, wait for it. We simply turn the go function into an async function. This allows us to use the await inside of it. Then we take the promise returned from start and await it, or in short, await start. As we've seen before, the await function does not really wait for the function, it waits for the promise that the function returns. And as you see, now the second go message is only printed after the third start message. What happens if we take a regular synchronous function that doesn't use await and simply add the async keyword to it. For example, let's say we have a function that just returns the number 40. Right now, its returned type is number. Once we mark it as async, it now returns a promise of number. But does that change how it behaves? Does it suddenly become asynchronous and introduces a delay? The answer is no. Since the function still returns immediately, the compiler just wraps the result in a promise that's already resolved. It behaves as if it runs synchronously, but it formally returns a promise. So yes, it's a promise, but one that's already done at the moment it's created. So that means this promise is never in progress. It's already created, resolved. Let's say we explicitly return a promise at the end of the function. Is it going to be a promise of promise? We already saw that the then operators know how to deal with that. They don't create a promise of promise, but rather flatten it into a normal composed promise. As you can see, the async compiler knows how to handle it too. If our async function ends by returning a promise of number, for example, the final result will be a promise of number, not a promise of number. In fact, the completion time of the composed promise returned by the function will be the completion time of the inner promise that we've returned. Let's say we have a series of functions that call one another. For example, function A calls function B, which calls function C, which calls function D. And let's say that function D returns a number, and let's assume that each function in the chain modify that number slightly and return a new number. In that case, all four functions return plain numbers. But now, imagine that we discovered that function D needs to fetch the number from the server. That means it must be asynchronous and return a promise. But because function C needs to wait for the value from function D, it now has to use await, which means it too must become async. And that means that function C now returns a promise instead of just a number. So that means that B also becomes async in order to use await, and so on and so forth. What we're seeing is that async-await is contagious. Once a function deep in the chain becomes async, the entire call chain above it changes. All the functions must now return promises, which also changes how they're called. This can lead to a refactor of your entire code base. That's why, if you suspect that a function might eventually need to become async, even if for now it runs instantly and is fully synchronous, it is a good idea to make it return a promise from the start. Just mark it as async without changing anything else in the code, and that will work. But let's say we want to run two asynchronous operations. We have two options. We can run them one after the other, sequentially, or we can run them in parallel. If we simply call both async functions but don't await them yet, their processes will begin immediately. Since we didn't await them, we're still in zero time, and both operations are already in motion. Each one gives us a promise that tells us when it finishes. In our example, the first promise finishes after 2 seconds, and the second after 3. But since they're both started at the same time, we can await the first one, which will take 2 seconds, and then await the second, which at that point only has 1 second left. If instead we want them to run one after the other, sequentially, we need to await the first promise before we even call the second function, before we even create the second promise. That way, they run strictly one after the other. This gives us control over whether we want our async tasks to run in parallel or sequentially. And this is called promise orchestration. Later in this series, we'll explore other ways to produce promises and even more interesting techniques to combine, synchronize, and orchestrate them. So stay tuned.